Hi everyone, welcome to Mathworld. This is Cambridge International AS and A-Level Further Mathematics Paper 1 for May-June 2022 and the code is 9231/11. Just for information, the questions in this paper is also the same as 9231/12, which is the paper 1-2. Okay, so let's get started. First question, let A be a positive constant. A. Use the method of differences to find summation r equals to 1 to n. R start from 1 to n. 1 over ar plus 1 multiplied by ar plus a plus 1 in terms of n and a. Okay, so first of all, we need to get the partial fractions of this rational function. So 1 over ar plus 1 multiplied by ar plus a plus 1. Okay, so now our variable is a r. So since the first term, the r with degree 1, and the second bracket, the r also with degree 1, we will treat these two as linear factors. So it will be a over ar plus 1 plus b over ar plus a plus 1. Okay, so by comparing to the left-hand side, in order to get the same denominator, I need to multiply the first rational function by ar plus a plus 1 and divide by ar plus a plus 1. And then for the second term, it will be b over ar plus a plus 1 multiplied by ar plus 1 over ar plus 1. Then I will be getting the same denominator as on the left hand side. Okay, once you have obtained this, then we can just cancel all the denominators. And the next equation is going to be the numerator. So 1 equals to a, all the numerators, brackets ar plus a plus 1 plus b bracket ar plus 1. Okay, so now to get the r value, I will let the factor be 0. So when I let ar plus 1 be 0, ar plus 1 be 0, which means my r is negative 1 over a. So I will get 1 equals to a bracket negative 1 over a plus a plus 1. Okay, so from here, my 1 equals to, so the first term is actually minus 1. So I'll get minus 1 plus a plus 1, which means my capital A is basically 1 over small letter a. That is my first solution. So now I will let the first factor be 0. So ar plus a plus 1 equals to 0. Okay, or probably I can just let r be any other numbers, then it will be easier instead of solving this. Alright, so I will let r be other numbers. Let's say r equals to 0. So when r equals to 0, 1 equals to a bracket a plus 1 plus b bracket 1. That's the easiest way. So now my b is going to be 1 minus this capital A, I will replace by 1 over small a, then multiply by a plus 1. So here will be 1 minus, multiply this 1 over a to the bracket, you will get 1 plus 1 over a. So when you open all the brackets, it will be negative 1 over a for the b. Alright, so now I will rewrite my partial fractions. So ar plus 1 bracket ar plus a plus 1 equals to, since 1 over a, I mean the capital A and the b has a common term which is 1 over a, then I can just factorize 1 over a from both of them. So it will be 1 over ar plus 1. My b is negative 1 over a. So once I factorize 1 over a here, I will have minus 1 over ar plus a plus 1. Okay, this is what I get from the partial fractions. Now to get the sum, okay, and applying the method of differences. So now, when method of differences means that it will involve two functions, fr and fr minus 1. So now I will let my bigger, I mean this second function be the fr, because that is fr. So AR plus A plus 1. Then my FR minus 1 is going to replace the R by R minus 1 here. So it will be A bracket R minus 1 plus A plus 1. So when I simplify, so I will get AR minus A plus 1, which is 1 over AR plus 1, which means my first function here, okay, this is my FR minus 1. And then this is my FR. Okay, so now I will consider the summation in the next step. So summation R from 1 to n, 1 over AR plus 1 times AR plus A plus 1. It will be the summation of R from 1 to n. Okay, so there is 1 over A outside. So that means I can just factorize the 1 over A, the small letter A. Then I consider the summation for these two terms. So it will be FR minus 1 minus FR. Okay, so now I may factorize a negative from the bracket. So I will get negative 1 over A summation R from 1 to n. Then FR minus FR minus 1. Okay, so now based on the method of difference, I need to substitute n into the first term, into the first r, and r equals 1 into the second term. That means now you are getting negative 1 over a, then fn minus, when you replace the r by 1, so 1 minus 1 is 0, so f0. Okay, remember just now our fi is this. So here I will rewrite my fr is going to be 1 over AR plus A plus 1. So now, to get the Fn, you just replace the R by n now. So it will be negative 1 over A, then 1 over AN plus A plus 1 minus F0, means that R is 0 now. So when R equals to 0, you get R A plus 1. Okay, so that's the solution for the first part. Okay, now B, find the value of A for which the summation R from 1 to infinity. Just now we found R from 1 to n, okay? So for the same function equals to 1 over 6. So for your information, summation R from 1 to infinity, 1 over AR plus 1 multiplied by AR plus A plus 1 equals to 1 over 6. So this summation from 1 to infinity is same as limit n tends to infinity for the summation from r from 1 to n. It is the same. Then equals to 1 over 6. So we have found the summation just now. I'm going to replace it by this result. So limit n tends to infinity, negative 1 over a, bracket 1 over an plus a plus 1 minus 1 over a plus 1. That equals to 1 over 6. Okay, so now from here we know that when n tends to infinity, 1 over an plus a plus 1 tends to 0. Okay, so which means the limits on the left hand side will be just negative 1 over a, then the first term becomes 0, then negative 1 over a plus 1 equals to 1 over 6. So now I can combine both. It will be 1 over a bracket a plus 1 equals to 1 over 6. So in order to get a, I will just consider the denominators. Alright, let me continue over here. So a bracket a plus 1 equals to 6. So now do expansion. A squared plus A minus 6 equals to 0. And when you simplify this, or when you factorize this, you will get A plus 3 bracket A minus 2 equals to 0. So A plus 3 equals to 0 means A equals to minus 3, or A minus 2 equals to 0 means A equals to 2. But then now, the question says, find the value of A, means that you are just expected to get one A value. So how to choose this A? Refer back to the question. Let A be the positive constant. Alright, so from here, I know that my A is going to be 2. So this is the solution for part B. Okay, now question 2. The points A, B, C have position vectors 4i minus 4j plus k, that is the OA. So OA equals to 4 minus 4, 1. Then OB equals to minus 4, 3 minus 4. OC equals to 4 minus 1 minus 2. Now, A, find the equation of the plane ABC, giving your answer in the form AX plus BY plus CZ equals to D. Okay, so now first of all, we need to find vector AB. So vector AB is OB minus OA, which is negative 4, 3 minus 4 minus 4, 4, 1. So I will get minus 8, 7, no, 3 minus the OA. Okay, wait. OA is 4 minus 4, 1. So this is minus. So 3 minus minus is 7. So 3 minus minus 4 is 7. Minus 4 minus 1, you will get minus 5. That is our AB. Then I need to find AC. Vector AC is OC minus OA. So which is 4 minus 1 minus 2 minus OA is 4 minus 4, 1. So then you will get 0, 3 minus 3. Okay, so now we need to get the vector n, alright? So the n is parallel to AB cross AC, so I need to count AB cross AC right now. So AB cross AC is basically the determinant of the, or you can say it is determinant, or you can just cross multiply both vectors. Alright, we have two methods to solve it. Okay, so what to do is, you can just consider first row. We'll consider first row, right? We'll consider first row. Then the sign is plus, and the remaining will be the, you need to count the remaining, the determinant of the remaining numbers. So it is plus. Okay, again it is a factor. So multiply, cross multiply. So I will get 7 bracket negative 3 minus 3 times negative 5. Put a bracket. Okay, so this is the vector product. Then next is cover the second row. So I cover this second row. Okay, the sign is minus. Then cross multiply. Minus 8 times minus 3. Then minus 0 times minus 5. Okay, lastly, consider the third row. So cover the third row. So now we need to count the determinant of the remaining terms. That means you'll get minus 8 times 3 minus 7 times 0. Okay, so from here, when you count, the first one is negative 21 plus 15. So you get negative 6. The second row, the brackets will be 24 minus 8 times minus 3 is 24. So 24 times another minus is negative 24. Then lastly, it is minus 24. Okay, so from here, I may factorize minus 6. So I get 1, 4, 4. And since I have mentioned just now that the perpendicular vector, which is the n from the plane equation, is parallel to the AB cross AC, then I can say that my vector n is basically 1, 4, 4. Okay, so now the equation of the plane ABC it is in the form of r dot n equals to a dot n. So r dot n equals to a dot n. And now I will express all this in Cartesian form. So the r will be x, y, z. Dot my n will be 1, 4, 4. Equals to my a is any point on the plane. So you can choose any points. I will choose the OA. Right, the points A. 4 minus 4, 1. So 4 minus 4, 1. Dot 1, 4, 4. Okay, so the scalar product of the left hand side will be 1x plus 4y plus 4z equals to, for the right hand side it will be 4 times 1 is 4. Second term is plus negative 16. Then the third term is plus 4. So from here I will get x plus 4y plus 4z equals to 8 minus 16. I will get minus 8. Alright, so we have formed the equation of the plane ABC. Alright, that's the answer. Okay, now B. Find the perpendicular distance from O to the plane ABC. Since we have found the plane just now, so I'm going to rewrite my plane equation. X plus 4y plus 4z is minus 8. So x plus 4y plus 4z is minus 8. Okay, so from here, the perpendicular distance equals to okay, so from here I can move the minus 8 to the left hand side. So I will get x plus 4y plus 4z plus 8 equals to 0. Okay, now we have a formula for perpendicular distance. So the O is actually the origin, so 0, 0, 0. These are the coordinates. Means that now you are going to replace the x, y, z by 0. Okay, so it will be 0 plus 4 bracket 0 plus 4 bracket 0, then plus 8. So we refer to this formula, and then it over square root of the coefficients of the square of the coefficient for all the variables. So the coefficient for x is 1, so 1 squared. Coefficient for y is 4, so therefore it will be 4 squared. Coefficient for z is 4 as well, so 4 squared. And put a modulus to make sure that the distance is positive. So from here, the numerator is 8. So 1 square plus 4 square is 17. 17 plus another 16 plus 17, yeah, so 16 plus 17, it will be another 33. It will be 33. Okay, so you can leave your answer in this form, or you can just calculate to 3 significant figures to get 1.39. So that is the perpendicular distance from the origin to the plane ABC. Okay, now part C. The point D has position vector 2i plus 3j minus 3k. So which means your OD equals to 2, 3 minus 3. Now find the coordinates of the points of intersection of the line OD with the plane. So now first of all, we need to find what is this line OD equation. Right? So I will say that equation of the line OD, R equals to A plus TB. So it's like this. This is your O. This is a D. So the A here is the point on the line. I would say that it is the origin. So or 0 plus T. The B is a direction vector. This is my direction vector, which is my OD. So which is 2, 3 minus 3. So when I simplify, this will be 2, 3 minus 3. Okay, and now to find the intersection points, since just now we have formed the plane of ABC in the Cartesian form, right, x, y, z. So I need to get the x, y, z from this equation, from this OD line. So I will change my R to x, y, z. Okay, and don't forget the t here. So from here I know that my x is basically 2t, my y is 3t, and then my z is minus 3t. Okay, so now substitute all these three values into the plane equation. So x plus 4y plus 4z is minus 8. So now replace. I will get, because they are intersecting. So when intersecting means that you are solving the simultaneous equations. So 2t plus 4 of 3t plus 4 of negative 3t equals to negative 8. So left hand side you will get 2t because the second and third term will be cancelled off. Then right hand side is minus 8. Therefore my t is basically minus 4. Once you get the t equals to minus 4, then we can get the position vector of the intersection points. Means I will just replace it here. Okay, therefore my x, y, z will be minus 4 of 2, 3 minus 3. So when you simplify, it will be minus 8, minus 12, and 12. Okay, let's go back to the question. Find the coordinates. Coordinates means it must be in the coordinates form. So I have to rewrite. So intersection point equals to minus 8, minus 12, and 12. So these are the coordinates of the intersection point. Okay, now question 3. The sequence of positive numbers u1, u2, u3, all these are positive numbers, is such that u1 is greater than 4 for n greater or equals to 1. Now, and given that un plus 1 is un squared plus un plus 12 divided by 2un. Now, A, by considering un plus 1 minus 4, or otherwise, prove by mathematical induction that un is greater than 4 for all positive integers n. So, since the hint is given, okay, so we will use this to prove the mathematical induction. So, first of all, let Pn be the statement, because now you need to prove this, un greater than 4. Okay, let Pn be the statement. Un greater than 4 for all positive integers n. Now we need to prove the base case, means that when n equals to 1. So now when n equals to 1, what is our u1? u1 is given in the question. It is given that u1 is more than 4. So given u1 is greater than 4. So that means you want to prove un is greater than 4. So now it is true for n equals to 1. So P1 is true. Okay, so now we need to assume n equals to k is true. So it means that now our Pn becomes Pk, and this is referring to uk plus greater than 4. Alright, so now we need to prove when n equals to k plus 1. So now we will use this expression un plus 1 minus 4, but now I will replace my n by k. So it means that uk plus 1 minus 4, it is, so refer to this expression and change the n to the k. So I will get uk squared plus uk plus 12 over 2uk minus 4. Okay, and now we need to prove this is greater than 0. Alright, so that the minus 4 move to the right side, it becomes greater than 4. So now get the same denominator. 2uk in the denominator. So numerators will be uk squared plus uk plus 12 minus this 4 times 2uk will be 8uk. Okay, you get the same denominator. So now simplify the numerators. You will get uk squared minus 7uk plus 12 divided by 2uk. And now it is a quadratic in the numerator. Therefore, we need to factorize. So once you have factorized, you should get two factors. The first is uk minus 4, and the second is uk minus 3. Then divided by 2uk. Okay, now from the previous case, we know that uk is greater than 4. Alright, so uk is greater than 4. Therefore, uk minus 4 will be greater than 0 because this value is greater than 4. So, and of course, uk minus 3 is also greater than 0, right? Because this is more than 4, uk. Then, of course, 2uk will be greater than 8. So, in general, numerators, it will be positive. Denominator also positive. So, the whole division is going to be positive. So, from here, I will say uk plus 1 minus 4 will be positive. Hence, your uk plus 1 is actually greater than 4. Okay, so we have proven the uk plus 1 is greater than 4 for pk plus 1. Alright, so that means pk plus 1 is true. So now you can make the conclusion by mathematical induction. un is greater than 4 for all positive integers n. Okay, so this is how we prove this. Now B, show that un plus 1 is less than un for n greater equals to 1. So I will move this un to the left hand side and prove that it is less than 0. Okay, in other words, it will be un plus 1 minus un less than 0. So I will start solving this. So un plus 1 minus un is basically, okay, so now un plus 1 is un squared, okay, use back this expression, un squared plus un plus 12 over 2un. So here will be un squared plus un plus 12 over 2un minus un. And now you need to get the same denominator. So I will get un squared plus un plus 12. So 2un times minus un, it becomes negative 2un squared. And now when you simplify, you will get negative un squared plus un plus 12. Okay, so if you need to factorize this, it's better for you to factorize the negative first before you get the two linear factors of the quadratic. So I will get, once you factorize the negative, remember you are dividing all the terms by negative. So I should get negative un, negative 12 over 2un. And now I can easily factorize this quadratic function. So I will get negative of un minus 4 times un plus 3 over 2un. So this is my un plus 1 minus un. Okay? So now I will continue side by side, then it will be easier for me to show you the result. So now from here, I will rewrite un plus 1 minus un is negative of un minus 4, un plus 3 over 2un. Okay, just now we have proven that un is greater than 4. Therefore, un minus 4, un is greater than 4, so greater than 4 minus 4, it will be more than 0. Un plus 3, also greater than 0. So 2un is greater than 8. So when you look at the whole expression right now, un plus 1 minus un, now these two are positive. Okay, the numerators are positive, denominators also positive, but unfortunately there is a negative outside. So it means that it is less than 0. Okay, the whole value becomes negative. So when this is negative, now you can just move the negative un to the right side because we want to show this. Then you will be getting the answer. Okay, so sure. So this is how we show this inequality. Okay, now question 4. The cubic equation 2x cubed plus 5x squared minus 6 equals to 0 has roots alpha, beta, gamma. Find a cubic equation whose roots are 1 over alpha cube, 1 over beta cube, and 1 over gamma cube. Okay, so I will rewrite the given equation first. Okay, since your equation in terms of x, then I will say that x equals to alpha, beta, gamma. And now I will let the new roots be y. So let y equals to 1 over alpha cube, 1 over beta cube, and 1 over gamma cube. So the relationship between x and y now is y equals to 1 over x cube. Okay, and now since you are given the equation in terms of x, I may get the x as the subject. So now my x will be 1 over y to the power of 1 over 3. Okay, so now substitute into the first equation, the given equation. So I will get 2 bracket 1 over y to the power of 1 over 3, then cube, because I'm replacing my x now. So plus 5 bracket 1 over y to the power of 1 over 3 squared, then minus 6 equals to 0. So from here, try to simplify first. Cube of y to the power of 1 over 3 is actually y degree 1. So I will get 2 bracket 1 over y plus 5 over, 5 over y to the power of 2 over 3, then minus 6 equals to 0. So to get the cubic equation, we cannot accept the fraction power. What to do is just keep the 5 over 2 power 5 over y to the power 2 over 3 as one side, okay, and then the rest on the other side. So which means here I will get 5 over y to the power 2 over 3 equals to, on the left hand side, then the other two terms will be moved to right side. So I'll get 6 minus 2 over y. And then now to eliminate the power, the 2 over 3, so I need to cube both sides. Okay, consider cube both sides. So now the numerator 5, you cube it, it will be 125. Denominator, when you cube it, it is y squared. So for the right hand side, basically you can use the Pascal triangle to solve. Okay, so if you remember, so Pascal triangle 1, 1, this is for degree 2. Now for degree 3, it will be 1 to 1. Sorry, degree 2, it will be a plus b squared. This is a plus b degree 1. Okay, the coefficients of the a and b. Then for the cube, right? So it will be 1, 1, front and back. Then you plus together, it will be 3. Here plus together is 3. So these are the coefficients for a plus b cube. So this is the Pascal triangle. Right, so this is a plus b degree 0. So otherwise you can just expand using the binomial expansion. So here I will get 6 cubed plus because here is 1, so 1 times 6 cubed is 6 cubed. Then the coefficient is 3, so 3 bracket 6 square, then negative 2 over y, plus the next coefficient is 3. Then now 6 square becomes 6 degree 1, negative 2 over y degree 2. Lastly, the coefficient is 1, so 1 bracket negative 2 over y degree 3. Okay, so now simplify all the terms on the right hand side. 6 cubed is 216. 3 times 6 square, it will be, okay, 3 times 6 square times negative 2, it will be negative 216. So I will direct simplify all. Then the next coefficient is going to be 72 over y squared. Lastly, this is minus 8 over y cubed. So left hand side rewrite. Now from here to get the cubic equation, so we times 3, we times y cubed to the whole equation. So the left hand term will be, left hand side will be 125y equals to 216 y cubed minus 216 y squared plus 72y minus 8. Now rearrange it to get the final answer. 216 y cubed minus 216 y squared. So 72y minus 125y, it will be negative 53y. Then minus 8 equals to 0. So that is the cubic equation. Okay, now B. Find the value of 1 over alpha power 6 plus 1 over beta power 6 plus 1 over gamma power 6. So 1 over alpha power 6 plus 1 over beta power 6 plus 1 over gamma power 6. All this will be the summation of 1 over alpha cube power 2. Right, so if my 1 over alpha cube means 1 over alpha cube, then 1 over alpha, beta cube, 1 over gamma cube. So from here I know that this is the square of the roots from this cubic equation. Okay, so before I proceed, I will just write here from 216y cubed minus 216y squared minus 53y minus 8 equals to 0. Summation 1 over y cubed, because the roots are y cubed, I mean the 1 over alpha cube, it will be minus b over a. Okay, so now let me do step by step. So my a is 216, my b is negative 216, my c is negative 53, d is minus 8. So summation 1 over alpha cube, which is the summation of the roots, it will be minus b over a, which is negative of negative 216 over 216, which is 1. Okay, then summation products of two roots equals to c over a. So it is minus 53 over 216. Then the multiplication of these three roots equals to d over a. So I will get, negative d over a. So it will be negative of negative 8 over 216. So when you simplify, this is 1 over 27. Okay, so now I'm going to use the formula summation square of the roots equals to square of the sum of the roots minus 2 of the product, sum of the product of the roots. Okay, it's like we have this formula. Summation alpha squared is summation alpha squared minus 2 summation alpha beta. Okay, which is similar to this. So now I have to replace all the values. So here is going to be summation 1 over alpha cube is 1. So 1 square minus 2 times the summation of the next value is negative 553 over 216. Okay, so now from here when you simplify, it will be 161 over 108. So that's the solution of part B. Okay, C. Find also the value of 1 over alpha degree 9 plus 1 over beta degree 9 plus 1 over gamma degree 9. We know that y equals to 1 over alpha cube. So if 1 over alpha degree 9 means that is the y cube. Okay, so in order to get sum of the y cube, so I will refer back to the equation, the cubic equation that we have formed. I just replace my y by the 1 over alpha cube, 1 over beta cube, and 1 over gamma cube. Then I am able to solve the equation. So I will rewrite now. So 216y cubed minus 216y squared, then minus 53y minus 8 equals to 0. So now my y cube is 1 over alpha degree 9. Okay, alpha degree, from here I will write our y cube equals to 1 over alpha degree 9, 1 over beta degree 9, and also 1 over gamma degree 9. So now replace. So 216, 1 over alpha degree 9 minus 216, 1 over alpha degree 6, because it's power 2. Alright, your y is 1 over alpha cube, 1 over beta cube, gamma cube as well. So then minus 53, 1 over alpha cube. So you can write here y equals to 1 over alpha cube. Then minus 8 equals to 0. So when y equals to 1 over beta cube, I'm getting 216, 1 over beta cube, beta degree 9, minus 216, 1 over beta degree 6, then minus 53, 1 over beta degree 3, minus 8 equals to 0. And y equals to 1 over gamma cube. So I will get 216, 1 over gamma degree 9, minus 216, 1 over gamma degree 6, minus 53 of 1 over gamma degree 3, minus 8 equals to 0. Okay, so now I let this 3 be 1, 2, 3, first, second, and third equation. So when I add up these 3 equations, okay, the first term, 216 will be in common. So I will write 216 bracket 1 over alpha degree 9 plus 1 over beta degree 9 plus 1 over gamma degree 9. The second term, the common is negative 126. So 1 over gamma degree 6 plus 1 over beta degree 6 plus 1 over alpha. Okay, the first one is alpha, not gamma. Then the last one is gamma degree 6. And same for the third term. When you plus together, the common is minus 53. So I will factorize negative 53 followed by 1 over alpha cube plus 1 over beta cube plus 1 over gamma cube. Now for the minus 8, you plus together means that you are minusing 8 for 3 times. Then equals to 0. Okay, so now since we need to get 1 over alpha 9 degree, 1 over alpha degree 9 plus 1 over gamma degree 9 plus 1 over beta degree 9. So it means that I will keep the first term on one side. Okay, so 216 of all this it will be 216 of the 1 over gamma 6, alpha 6, beta 6 plus gamma 6, then plus 53 of 1 over alpha cube plus 1 over beta cube plus 1 over gamma cube, then plus 24. 8 times 3 is 24. Okay, so here at last I will get the summation here is going to be 1 over 216 divided by 216 times this term. 1 over alpha 6 plus 1 over beta 6 plus 1 over gamma 6. This is basically summation 1 over alpha cube squared. Alright, so we have done just now. So which is the previous answer? 161 over 108. So 161 over 108 plus 53. The next one is going to be summation 1 over alpha cube. So summation 1 over alpha cube, again from the parts B, which is 1. So here multiply by 1. Then plus 24. Okay, so when you simplify all of this, you will be getting 133 over 72. So that's the solution for this question. Okay, now question 5. The curve C has equation y equals to 2x squared minus x minus 1 over x squared plus x plus 1. A, show that C has no vertical asymptotes. Okay, no vertical asymptotes. This is show. And state the equation of the horizontal asymptote of C. So now, let me copy the question first. Now, when we need to solve for vertical asymptotes, basically we are referring to the denominator. We will let the denominator be 0. Okay, so I will let x squared plus x plus 1 equals to 0. So to show that no asymptotes means that you have to show there's no root for this quadratic equation. So now I will show using discriminant. So my A, which is a coefficient for x squared, is 1. B is a coefficient for x, which is 1 as well. C also 1. So now when you count the discriminant, b squared minus 4ac, it will be 1 squared minus 4 times 1 times 1. So you will be getting minus 3 less than 0. So now, which means no root for the quadratic equation. Okay, so if no roots for this quadratic equation means that you can't find any vertical asymptote. Therefore, C does not have vertical asymptote. If you can find the x value, then that will be the vertical asymptote. And now state the horizontal asymptote. So horizontal asymptote is solved by comparing the degree. Okay, so if it is the same degree for the numerator, the highest degree for numerator and denominators are the same, which is 2 here, here 2, here also 2, then we will just compare the coefficients. So from here, I will just write down horizontal asymptote. So horizontal asymptote y equals to 2. Okay, because it has the same degree for the numerator and denominator. The same highest degree for the numerator and denominator. Alright, so that's the solution for A. Okay, B, find the coordinates of the stationary points on C. So stationary points means dy dx equals to 0. I'm going to copy the y. Okay, so now differentiate using quotient rule. So square the denominator, rewrite the denominator, and then differentiate numerator. So when you differentiate 2x squared, you will get 4x. Minus x becomes minus 1. The minus 1 becomes 0. Then minus, rewrite the numerator. differentiate denominator now becomes 2x plus 1. Okay, so when you need to solve this, normally we will factorize the common term in the numerator, but unfortunately there is no common term, therefore we need to do expansion. So when you expand, okay, just expand one by one. So I will get 4x cubed. X squared minus 1 is minus x squared. So then 4x squared. X times minus 1 minus x. 1 times 4x minus 1 will be 4x minus 1. Okay, minus bracket. And same goes to the next. Right, just do expansion. 2x squared times 2x will be 4x squared, 4x cubed. 2x squared times 1, positive 2x squared. Negative x times 2x, negative 2x squared. Negative x times 1, negative x. Lastly, minus 1 times 2x plus 1, it will be minus 2x minus 1. Then over, please do not expand the denominator. So denominator, just leave it. Okay, now simplify the terms. Probably I can just do the expansion first. So 4x cubed. So I simplify the minus x squared plus 4x squared. It will be plus 3x squared. Minus x plus 4x plus 3x. Then minus 1. This minus you can bring in. Okay. So at the same time you also simplify. So I will get negative 4x cubed. Then now, okay, 2x squared and negative 2x squared will be cancelled off. So I will skip it. Then negative x, negative 2x, negative 3x. So negative 3x times the negative outside, it will be positive 3x. Lastly, minus 1 times minus is plus 1. Then over square of x squared plus x plus 1. So now further simplify. Okay, 4x cubed and negative 4x cubed will be cancelled off. Then I will get minus 1 and plus 1 cancel off. Alright, so rewrite the remaining terms. 3x squared. 3x plus 3x, it will be 6x. Then over square of the denominator. Square of the bracket. So when dy dx goes to 0, we know that denominator, no need to consider. So the numerator will be 0. I will factorize the 3x. So 3x bracket x plus 2 will be 0. Means that my x will be 0 or minus 2. Okay, so now let's look at the question first. It's mentioned coordinates of the stationary points. So more than one point here. Now, once you have found the x, then to get the y, substitute back into your curve equation. Right? So when x goes to 0, my y is 2x squared minus x minus 1. So 2x squared minus x minus 1 over x squared plus x plus 1. So x squared plus x plus 1. Right? So when x goes to minus 2, my y equals to 2x squared minus x minus 1 over x squared plus x plus 1. So I just simplify. So the first term is minus 1 over 1, which is minus 1. The second is 2 times minus 2 squared is 8. Then minus minus is plus 2. So 8 plus 2, 10. 10 minus 1 is 9 over minus 2 squared is 4. 4 minus 2 is 2. 2 plus 1 is 3. So I get 3. So from here, I will just make a conclusion. Stationary points equals to 0, minus 1, and negative 2, 3. Okay, so that's the solution of this part. Okay, now see sketch C stating the coordinates of the intersections with the axes. So now I will copy back the question first. The curve first. 2x 2x squared minus x minus 1 over x squared plus x plus 1. So for the intersections with the x's, I need to count. When x goes to 0, my y is minus 1 over 1, which is minus 1. When my y equals to 0, okay, 0 is 2x squared minus x minus 1. So I will get 0 equals to 2x plus 1 and x minus 1. Therefore, my x equals to negative half and 1. So from here, I will get the points 0 minus 1, negative half, 0, and 1, 0. Okay, these are the points intersection. These are the intersection points with the axis. And then don't forget that just now we have found the stationary points 0, minus 1, minus 2, and 3. So stationary points 0, minus 1, then minus 2 and 3. Oops, I have written too much, no space for me to sketch, then I need to write it here. Stationary points okay, so stationary points 0, minus 1, and then negative 2, 3. Okay, let me erase this. And then don't forget the horizontal axis is at y equals to 2. Okay, horizontal, not axis, the asymptote. Y equals to 2. So now, based on all this information, we can easily sketch a graph. So my graph. Okay, now let's look at the y value. The y value I need to cover up to 2. Okay, so let's say here is 2. Let's say here is the y I need minus 1. Okay, let's say here is x-axis, y-axis, 1, 2. Here is minus 1. Okay, my x I need half, negative half and 1. So here is 1 and here is 1. Minus 1. That means here is negative half. Okay, so now I mark the points. 0, minus 1. 0, minus 1. And then minus half, 0. Then 1, 0. Okay, the asymptote is at y equals to 2. So asymptote is at y equals to 2. This is my horizontal asymptote. Don't forget that I have a stationary point at minus 2, 3. So let's say here is minus 2. So minus 2, 3. Let's say here is 3. Okay, now since this is the y equals to 2 is an asymptote, means that when the x tends to infinity, the y will tend to this horizontal line, the dotted line. This is y equals to 2. Okay, which means, and at the same time, this 0 minus 1 is a stationary point, means that it might be maximum or minimum. But by looking at this, most likely it is a minimum point because we want to join these two intersections as well. So my graph will be like this. Okay, and this point, minus 2, 3, is going to be maximum point. Alright, so this is my graph. Make sure your graph will not increase, okay, when it tends to infinity. When the x tends to infinity. So it will tend to y equals to 2. Alright, so this is my y equals to 2x squared minus x minus 1 over x squared plus x plus 1. Here is 0. Okay, this is the graph. right? So now part D, sketch a graph with equation now with the modulus. So it means that you have to flip the negative part and state the value of x, sets of values of k, for which a modulus graph is equals to k has 4 distinct real roots. Alright, so now I will copy back this graph, but I will flip this negative part, or this flip. So it means that instead of -1 is the 0 minus 1 is the minimum point, now becomes maximum point. So here 1, 2, 3, -1, -2. Then here is -1. Here is 0. Okay, so all my other points remain the same, except the negative part, except those below the x-axis. Okay, so this minimum point becomes maximum point. Not to say maximum point, you flip it to be +1, then intersection with the axis will be 1 and -half. Still the same, 1 and -half. Maybe my -1 I should adjust a little bit. So 1, -half. Okay, another point is at -2, 3. So not much difference. But then now go down. After that, flip. Okay, it is not a straight line. Make sure you didn't draw a straight. You do not draw a straight line. Then here is going to be this. Okay, so draw a smooth graph. So let's check back. Okay, previously like this. So okay, so this is your graph. Y equals to modulus. Okay, now for the next part, state the set of values of k for which the modulus graph equals to k, means that this is the second y, this is y1, this is y2, has 4 distinct roots. So how to solve this is you need to draw a horizontal line, because y1 equals to k means horizontal line, 4 distinct roots. So I can just let this be k. Now let's check. If it is here, this is a k, which means it's 1, you will have 1, 2, 3. 3 roots only, because it is, at this point, you will get equal root. Okay, therefore, your k value will be between 0 and 1. Other than that, it will be less than 4 distinct roots. So from here, I know that my k is going to be 0 to 1. Cannot be exactly 1, because when exactly 1, the horizontal line, the green dotted line is touching the intersection with the y-axis, means that you will get 2 repeating roots. Okay, so that's all for this question. That's all for this D. Right, so now for number 6, the curve C has polar equation r squared equals to arctangent half theta, where theta defined from 0 to 2 inclusive both. Now A, sketch C and state. in exact form the greatest distance of a point on C from the pole. So now to sketch a graph, we need to calculate the values. Right, I will let the theta be 0, then 0.5, after that 1, 1.5, lastly 2. So remember, this is inverse tangent, so better to convert to change the mode of the calculator to radians. Alright, so now your r square is inverse tangent half theta. That means now your r is square root. Okay, so when you calculate, the first is 0, the second is 0.49, the third is 0.68, then 0.80, and this is going to be square root of 1 over 4 pi, which is 0.89, because you need to get your answer in exact form for the greatest distance. So that is the answer of the last value. Okay, so now when you sketch a graph, this is theta equals to 0. Okay, so you count when theta equals to, you measure theta equals to 0.5, 1, 1.5, and 2. So basically, at last, you'll be getting this. Okay, this is your graph. R squared is inverse tangent half theta. Okay, and now state in exact form the greatest distance. So this is a pole. So greatest distance is basically the R value when the theta is 2. Alright, so now from here, I know that greatest distance of a point on C from the pole is square root of 1 over 4 pi. Okay, that's all for A. Now B, find the exact value of the area of the region bounded by C and the half line theta equals 2. So now area is half integrate r square d theta. So the region is actually bounded by the graph and the line theta equals to 2 means that it is from 0. Okay, 0 to 2. And now when I replace the r value, it is inverse tangent half theta. Okay, so how to integrate this? Right? For your information, we only have differentiation of inverse tangent x over a. It will be a over a square plus x square. But we do not have the formula for integration of inverse tangent. So now, since you only can differentiate the inverse tangent half theta, which means this inverse tangent half theta must be the u. Okay, so we have to apply the the integration by parts right now. So it'll be half 0 to 2, 1 times inverse tangent half theta, because you only can differentiate inverse tangent half theta. Therefore, the inverse half tangent theta, it would be u. So now I will let u equals to inverse half tangent theta. Then my dv dx, or I will say dv d theta, equals to 1. So when you compare this, compare with the inverse tangent x over a, that means this is basically inverse tangent theta over 2, which means now my x becomes theta, my a becomes 2. So I can directly replace this formula. So du over d theta is 2 over 2 square plus theta squared, which is 2 over 4 plus theta squared. And then my v is to integrate 1 with respect to theta. Therefore, it is just theta. Okay, now to recall the by parts formula, So it is integrate u dv over dx equals to uv minus integrate v du over dx. Now, since here it is with limits 0 and 2, so I will consider limits a and b. So this will be my new formula. Okay, so now replace the formula. So I will get half uv. So now my uv. So put a bracket, theta inverse tangent, half theta with limits 0 to 2 minus integrates from 0 to 2 v du d theta. V du dx means v du d theta. So v du d theta. So theta bracket 2 over 4 plus theta squared d theta. Okay, so now when I replace half, now replace the theta by 2. So 2 inverse tangent, half times 2 is 1, then minus 0, then minus integrate 0 to 2. I will combine, so 2 theta over 4 plus theta squared d theta. Okay, so now half of inverse tangent 1 is basically pi over 4. So for the next integration, remember, integrate f prime x over fx dx is ln fx plus c. Okay, so when you differentiate theta squared, it is 2 theta, which means this 2 theta over 4 plus theta squared is exactly this form, which means now my function f or my function theta is 4 plus theta squared. Or on the other words, this integration is basically ln of 4 plus theta squared according to this ln formula. And don't forget to consider the limits. So from here, okay, so I will get half of pi over 2 minus ln, put a bracket, replace the theta by 2, 2 squared plus 4, it will be 8, minus ln 0 squared plus 4, it will be 4. So at last, I will get half of pi over 2 minus, alright, so now to simplify the ln, we use a formula, ln A over B is ln A minus ln B. So now I will get ln 8 over 4 because of minus. So you will get pi over 4 minus 1 over 2 ln 2. Okay, so that is our area of the region for this polar curve. Alright, now C. Now consider the part C where the theta is defined from 0 to half pi. Show that at the point furthest from the half line, theta equals to half pi. Theta squared plus 4 multiplied by inverse tangent half theta sine theta minus cos theta equals to 0. That's the first part. And verify this equation has a root between 0.6 and 0.7. So we have to solve two parts right now. So for your information, the point furthest means that this is a maximum. Okay, so maximum point. So that means now we need to find the x equals to r cos theta. We know that x equals to r cos theta. So now your r squared was inverse tangent half theta. Okay, therefore your r is going to be degree half of this inverse tangent. So then I will write my x equals to degree half of inverse tangent multiplied by the cos theta. So now dx over d theta. To differentiate this, we need to apply the products rule. So keep the first term. differential cos theta is negative sine theta plus, keep the cos theta, differential degree half, I mean the first term, bring down the half, the inverse tangent, half theta, the degree becomes negative half, and now differentiate inverse tangent theta we have solved just now. It will be 2 over 2 squared plus theta squared, so 4 plus theta squared from the previous part. Okay, so to simplify this, we need to factorize the common term. Let's check any common term. There's no common term, so now I will rewrite. So minus sine theta multiplied by inverse tangent half theta degree half. Then for the second term, we can simplify half and 2. Okay, so I will get plus cos theta over 4 plus theta squared. Then you see the negative degree half here, I will bring it down. 1 over inverse tangent half theta, then degree half. Right, or I will say that the half should be at the back. Everything. Okay, so now, since I have a denominator 4 plus theta squared and together with the degree half of this inverse tangent, 1 over inverse tangent, I can factorize the whole term now. So I will factorize 1 over inverse tangent half theta degree half together with 1 over 4 plus theta squared. Okay, then I will get negative 4 plus theta squared sine theta. Okay, there's a negative here, so negative already taken out. Then now, when you factorize degree negative half from the positive half, that means you will have inverse tangent half theta. Okay, then the last term will be plus cos theta. Alright, so from here, I will let my dx theta be 0 because we need to find the furthest. So when dx theta be 0 means that this whole square bracket will be 0. So I will get minus 4 plus theta squared sine theta inverse tangent theta half theta, then plus cos theta equals to 0. Okay, this is what we get now. So now let's check. We need theta squared plus 4 inverse tangent half theta sine theta minus cos theta equals to 0. So now I need to just move all the terms to the right hand side because I need to get this positive and the cos theta is negative. So 4 plus theta squared sine theta inverse tangent half theta minus cos theta equals to 0. So we have shown this. Okay, done the first part. Now, second part, verify that this equation has a root between 0.6 and 0.7. So now, let f theta be the terms on the left hand side. So to verify that the root, so the root is actually the unknown in the equation, which is our theta, between 0.6 and 0.7. So now I need to let my theta be 0.6 and 0.7. So now 4 plus 0.6 squared sine 0.6 multiplied by inverse tangent 0.6 divided by 2, which is our half theta, minus cos 0.6. Alright, so since you need to count the value in terms of inverse tangent and also sine, so make sure you change the mode of the calculator to radians. So f 0.6, it will be negative 0.108. This is a negative value. Now calculate f 0.7. This will be 4 plus 0.7 squared sine 0.7 inverse tangent 0.7 divided by 2 minus cos 0.7. So at last, you will be getting 0.209, which is positive. So now according to sign change rule, since you get one positive and one negative, therefore there will be a root in between 0.6 and 0.7. So you just write f 0.6 less than 0 and f 0.7 greater than 0. There is a sign change. Hence, the equation has a root between 0.6 and 0.7. Okay, so that is how we verify the root. Now, question 7. The matrix A is given by A equals to 1, 2, 3 for first row, 4k6 for second row, and 7, 8, 9 for third row. Find the sets of values of k for which A is non-singular. Non-singular means the determinant of the matrix is not 0. So now, the determinant of matrix A, 1, 2, 3, 4k6, 7, 8, 9 is not equal to 0. So to get the determinant, we need to fix one row or column. So now I'm fixing first row. Okay, I fix first row, so I will label the values on the first row as plus minus plus. So when you cover the first row, right? So when you cover the first row here and consider first column, right? Consider first column. So the cross out is 1. So I will write plus 1. The remaining will be k6, 8, 9. Then minus. So now we consider second column. So now you cover the second column. Okay. So now the remaining will be, okay, the cross out is minus 2. The remaining terms will be 4, 7, 6, 9. And then the third column, the remaining terms will be 4, 7, k8. I consider all the columns first. So 4, 7, k8. Then not equal to 0. Okay, so when you count these determinants, 2 by 2 determinants is basically the cross multiplication. So I will get plus 1 bracket 9k minus 6 times 8, 48, minus 2 bracket 4 times 9, 36, minus 7 times 6, 42, plus 3 bracket 4 times 8, 32, minus 7k, and it is not equal to 0. So now I continue over here. So 9k minus 48. So when you times in, I will get plus, negative 72. Then minus 2 times minus 42, it will be plus 84. So 3 times 32, it will be plus 96. Then the other one is minus 21k, which is not equal to 0. So when you get the total of the k, alright, 9 minus 21k is minus 12k. Then the sum of the constants will be plus 60. Then it's not equal to 0. So from here, I know that 12k is not equal to 60. Therefore, my k is not equal to 5. Okay, that's the solution for A. Now, given that A is non-singular, find in terms of k the entries in the top row of A inverse. So because of non-singular, then the inverse function as inverse matrix exists. So now from here we know that the determinant of A is basically, okay, this is the determinant of A, right? Because I started with determinant of A is not equal to 0. So now I will write determinant of A equals to negative 12k plus 60. Alright, so now we are interested to get the entries in the top row of A inverse. So now entries, so I will just write down here. Okay, so if you still remember the entries of the third row, I mean the entries in the A inverse, it is 1 over A, then the adjoint A, right? So now I will get 1 over, here you can write 60 minus 12k, okay, then now when you consider the first one, the sign is plus, okay, the sign is plus, so I will write plus here. Then the determinant of 2 by 2 matrix will be, okay, now I will erase all this. Alright, so when you consider, you cover first row and first column. So you get 6k, 6, 8, 9. And now I consider by rows. So k, 6, 8, 9. Okay, so now I can simplify first. It will be 1 over 60 minus 12k multiplied by cross multiplication. So 9k minus 48. So now here, 9k and 48, the common is 3. So I will get 3k minus 16. And then for the denominator, the common is 12. So 12 bracket 5 minus k. Right? So the 3 and 12 can be cancelled off, can be simplified. I will get 3k minus 16 divided by 4 bracket 5 minus k. That is my first entry in the third row, in the top row. Okay, now my next one is going to be 1 over 60 minus 12k, then the sign is minus. Okay, now what I need to do here is, now for the inverse function, if inverse matrix, if you still remember, we need to get the adjoint matrix. Adjoint matrix is actually the transpose. Okay, so which means now instead of horizontal, instead of considering the first row and second column, now I'm considering first column and second row. I fix this. Okay, so now my remaining numbers will be 2, 3, 8, 9, and then the sign is minus. So I'm considering this now, and no longer horizontal, no longer the row. Okay, so I will write 2, 3, 8, 9. So then this will be 1 over 60 minus 12k. Then we'll cross multiply. Okay, don't forget there is a negative outside. So 2 or negative, I just put outside, it will be easier. So 2 times 9, 18, minus 8 times 3, 24. Okay, and again, now I factorize. So 18 minus 24 is minus 6. Minus 6 together with minus 1 is 6. Over 12 bracket 5 minus k. So the 6 and 12 can be simplified to 1 over 2 bracket 5 minus k. Okay, then the next one is going to be 1 over 60 minus 12k. And now the sign is plus. Okay, so for the third entry in the top row of A inverse, now we consider, okay, this is the k. We consider the third row. Okay, so the remaining will be 2, 3, k, 6. That will be the remaining entries. So now again, I get 1 over 60 minus 12k multiplied with 2, 6. 2, 6 is 12. 2 times 6 is 12. Then minus 3k. And again now you factorize the 3, which is in common. 4 minus 1k over 12 bracket 5 minus k. So again, the 3 and 12 can be simplified. I will get 4 minus k over 4 bracket 5 minus k. Okay, so these are the entries in the top row of A inverse. Okay, part C. Given that B equals to first row 1, 0, 0, second row 0, 1, 0. Give an example of matrix C such that BAC is 2, 1, K4. Okay, so now let me rewrite my A first. My A 1, 2, 3, 4, K, 6, 7, 8, 9. So 1, 2, 3, 4, K, 6, 7, 8, 9. So now my BAC, so I get my BA first. BA will be 1, 0, 0, 0, 1, 0. This is my B. Multiply with 1, 2, 3, 4, K, 6, 7, 8, 9. Okay, so from here, the B is matrix with dimension 2 by 3, 2 rows and 3 columns. Then my A is 3 by 3. So when I simplify this, the multiplication should be 2 by 3. So now I do the expansion first. It will be 1 times 1, which is 1, plus 0 times 4 is 0, 0 times 7 is 0. Okay, that's my first entry. Then 1 times 2 is 2, 0 times the rest is 0. Right, so I will just write 1, and then the second is 2. Then 1 times 3 is 3, 0 times 6 plus 0 times 9 is 0. Now then the second row will be 0 times 1 is 0, plus 1 times 4, I get 4. Then the next one is row times column. I will get 1k. Basically just consider the middle value. Then this is 6. Okay, now BAC is 2, 1, K4. Okay, so now your BA is 1, 2, 3, 4, K6. Then here is 2, 1, K4. Okay, just for information, for BA, this matrix, the order or the dimension is 2 by 3. So here 2 by 3. Then the answer here is 2 by 2. So from here, I need to get 2 by 2 for the final answer, means that I must eliminate the 3. So here is going to be 3 by 2, so that the 3 can be cancelled off. Okay, so now I know that my C will be 3 by 2. So let's say here is 3 rows, 2 columns. So I let it be A, B, first row, C, D, second row, E, F, third row. Okay, this is my matrix C. So now, when I do expansion, 1 times A will be A, plus 2 times C, 2C for the first entry, plus 3E. Okay, when you do expansion for this, row times column. Now row times column. So I will get B plus 2D plus 3F, then followed by second row and first column. So 4A plus KC plus 6E, then second row times second column, 4B plus KD plus 6F. This will be my BAC. That equals to 2, 1, K4. Okay, now we need to find the values for A, B, C, D, E, F, which is our matrix C. So by looking at the left and right side, you can actually do the comparison. Okay, I will say that, okay, you see the K here, this is also K, which means when you compare the KC with K, that means my C is 1. Okay, then when you compare 4 with this, 4B, so this is one of the choices. So 4B is 4, that means my B is 1. Then when you compare 1 here, okay, if here 1, here B is 1, Done. So C also 1. Okay, so which means now I will say that my A and E will be 0. Right? So my A equals to E equals to 0. Then when I refer to the 4 and 4B plus KD plus 6F, I will say that my D and F equals to 0. This is one of the options. Right? That's why my C can be, now I rewrite, my A is 0, my B is 1, C is 1, D is 0, E and F also 0. So that's why the question says, give an example of the C. So you can let it be any values as long as it satisfies all these 4 equations. Alright, all these 4 equations when you compare. So this is the one of the matrices C. Okay, so now D, find the sets of values of K for which the transformation in the xy plane represented by 2, 1 first row, K4 for the second row, has 2 distinct invariant lines through the origin. So when invariant lines through origin means that the points will map into itself, and also y equals to mx, right, because of origin. So now I will start with capital X and y equals to mx and y. So now my m is 2, 1, K4. That is my transformation matrix. So now I will replace it. 2, 1, K4 multiplied by small x and small letter y. Then here it will be row times column. Again, I will get 2x plus y for the x, capital X. For the capital Y, it will be kx plus 4y. Okay, so since invariant lies through origin, that means your y equals to mx. Okay, I will say that this is capital Y. So now we can connect these two coordinates. So when y equals to mx means that kx plus 4y equals to m of 2x plus y. So now I will replace my small y by m small x. So kx plus 4 of mx, because my y is mx, equals to m of 2x plus mx. Okay, so you do expansion. Kx plus 4mx equals to 2mx plus m square x. Now rearrange this to get, now before you rearrange, you will notice that all the x can be cancelled off. That means I will divide by x first. So I will get k plus 4m equals to 2m plus m square. Now you will get the quadratic equation in terms of m. Now rearrange this, m square plus 2m minus 4m minus k equals to 0. So at last, you will be getting a quadratic equation which is m squared minus 2m minus k equals to 0. Okay, now, by looking at the question, there are 2 distinct invariant lines. Means that here you will get 2 different m's. So when 2 different m's, that means the discriminant will be greater than 0. Alright, so a equals to 1, b is minus 2, c is minus k. So I will start with b squared minus 4ac greater than 0. So replace the b by minus 2. Then minus 4, a is 1, c is minus k, then greater than 0. So you will get 4 plus 4k greater than 0. So from here, 4k is greater than negative 4. Hence, your k will be greater than minus 1. Okay, but then the question says find the set of values of k. Now, your transformation matrix has k. So we have a condition here. The determinant of m cannot be 0. Right? So now, determinant of the m. So the m equals to 2, 1, 4k, 2, 1, k4. this cannot be 0, which means 2 times 4 is 8, minus k cannot be 0, so your k cannot be 8. Alright, so it must satisfy both conditions, which means now basically your k is greater than minus 1, but cannot be 8. Okay, so that's the solution for this question. Alright, so that's the end of this video. Alright, so thank you for watching this video. If you enjoy watching my video, please subscribe to my channel. Thank you. Bye.